Okay, great. So on this wonderful Sunday morning, we are here for our Plato talk. And Plato talks are basically a free series of talks by experts in the industry, where they would explain a complex topic for kids and especially for you, so that you get to know the insights of how the latest technology is and how the latest technologies are used in these kind of industries, right? So that you can also build a lot of interest and have some inspirations to actually get into this subject, right? So today's topic, we are going to have it on the future career in space industry, right? For today's kids. And before we begin, I would like to just know you whether you are very active, because it's quite early in the morning, and I want to just check, how active you kids are. So for that, we have a small fun quiz before we begin. Okay. So this is going to be a pictorial quiz. I'll be showing you one picture and I would be asking one question. And based on the question, you have to answer and you have to put your answer in the chat box. Okay. Hope you children are excited. Ready? Okay, great. So first picture I have here is a triangle with the word written in it, right? So the question for this is, what is the color of orange? Okay, you have 10 seconds to answer. What is the color of orange? Okay, I'm seeing a lot of answers with blue, then orange, then some are white. Yes, last 5 seconds. Okay, great, great. Yes, so the time's up. So the correct answer to this question is white, right? Because here in this picture, the word orange is written in white color, right? So the color of orange is actually white, right? So kudos to all the kids who said it is white, right? You are correct and you are super active, right? For others, do not worry. I have another question for you, right? And the second question of the day is, I have an a blue square, right? And with the word blue. So the question for this is, what color is the word blue written in? What color is the word blue written in? I repeat the question again. What color is the word blue written in? Last 5 seconds. Okay, here we go. So the correct answer to this question is actually yellow, right? I'm seeing that all of you mostly have said it is yellow. So you're correct. So the answer to this question is yellow itself, because the word blue is written in yellow color. Okay, great, great. So hope you children are now very active and ready to start the session. Yes. Okay, great, great. It's been an honor welcoming our chief guest, Ms. Vaidehi, right? So Ms. Vaidehi is with us. So to give a little bit of background, so welcome, Ms. Vaidehi. Hope you're doing fine.
Hello, Vasant. I'm fine.
Okay,
Good
great.
morning, everyone. Am I audible?
Yes, yes, you are.
Okay.
Great. So Ms. Vaidehi, as is a recent IIT Kanpur alumnus and is here today to help us understand the future of space industry, right? Especially for kids. And also, she is working in an amazing startup, which is called Skyroot Aerospace. So they are working in the next generation space technology. So Ms. Vaidehi is here to give us some insights on how space industry is looking like and what are the scopes and what is currently happening there, right? So I wanted to understand, from her as well, on how she has taken this as a career option and what are the future synergies that kids today can have, right? That is the brief discussion we are going to have, right? So first of all, when I got to know about Vaidehi, it struck me as a very unique career, right? Not every day that we actually go and develop a career in space, but a lot of us would have had this passion. Even myself, even I wanted to become a pilot at an young age, but down the line, some way I have just drifted to an obvious things, right? So want to understand from you whether it's a very unique career option you took, right? So I just wanted to get some insights on it, in where it all start, what made you develop interest in space and technology. Can you shed some light on that to us?
Yeah, correct. So to begin with, I'll start with the school days and all. So I was always good in maths and science, doing well in the competitive exams, apart from the, academic exams which go on in schools and all. And it was eventually, it was obvious that eventually down the line after my like board exams, 12th board exams, I'd want to become an engineer, right?
Mm-hmm,
And then, yeah, and then obviously every child, he feels like he wants to study. If he wants to do engineering, he has to do it from the, topmost universities in India, right? So an obvious choice is IITs and NITs.
mm-hmm,
So, like, I in 11th and 12th, I started preparing for JEE and, eventually got a seat into IIT Kanpur.
mm-hmm,
And, the rank which I had, I could not get like the well sought out engineering disciplines such as electrical engineering, computer science engineering. I was more getting disciplines like metallurgical engineering, civil engineering,
mm-hmm,
and mechanics and mechanical engineering.
mm-hmm,
And then there was more like this, which is aerospace engineering.
mm-hmm,
And to me back then, and like after my boards, aerospace just sounded very fascinating. It seemed like a very relevant, not relevant, but it seemed like it is something very fascinating, out of the box. And it felt like at that time it would be something. It would make me unique to pursue this field. Right. And that was the time when, we were listening about Kalpana Chawla, Sunita Williams. These were the astronauts who had, made India proud by being the women astronauts of Indian origin and all. And it quite kind of, back then I had this notion that to become an astronaut, you have to, get into something like aerospace engineering. So with all this background thinking in mind, I was very adamant that no, I want to select aerospace engineering and see what all the subjects are there. So that's how I ended up studying aerospace engineering in college. I'll just actually my webcam is it's working, but you have disabled it.
oh, okay. Just give me a minute. Yeah.
Yeah, yeah.
Sure. If you can, also show us, what you have done and how you have come here, then it would be also great. Yeah.
Correct,
Mhm.
correct, correct. I'll share my screen.
Yeah.
Yeah, is my screen visible?
Yes. Yes.
Okay.
Mhm.
I'll just put it in presentation format.
Yeah. Yeah.
How do I actually do it here?
You would see the slideshow option in the right side. Right side. Yeah. Near to share. To your right.
Oh, okay.
Mm. You can see
Yeah.
a slideshow.
Fine.
Yeah.
Yeah, yeah, correct.
Mm, mm,
Yeah. So as already told by Vasant, I just start again. So
mm,
hello everyone, I am Vaidehi.
mm,
And as told by him, I completed my master's and bachelor's degree in aerospace engineering from IIT Kanpur. And as of now, I'm working as an aerodynamics engineer in a startup known as Skyroot Aerospace. So Skyroot Aerospace, it is a startup which aims to make spaceflight affordable, reliable, and regular, and most importantly, open space to the common people. And I here also I'm mentioning that instead of pursuing degrees like computer science, electrical engineering, during my college time I chose to pursue aerospace. I was just fascinated by the term, and yeah, that's how it all began. So
Okay, okay, got it.
yeah, yeah, yeah.
And how it's been in your daily life, and how it is going now. How is your day like at Skyroot Aerospace? And also you can
Correct,
share
correct.
something on what you've been working on.
Correct, correct, correct.
Mm,
So the thing is, this Cairo Aerospace, I'll just tell something about the company. It is the first private company in India to manufacture its own rockets. And all of you must be knowing that what actually rockets do. Rockets are actually launch vehicles that go into space, and they carry the satellites, which can then be, separated from the rocket and then set into some orbit around the Earth. So that's the basic job of a rocket. So Skyroot is majorly, concerned with the development of these rockets to, take satellites from customers and send them into space. So, and it is aiming to manufacture a rocket in a very low price, so that normal people like us, if we want to have a separate satellite of our own and send it to space, so that we can have a security monitoring through space for our home, or say our anything of our value of us, if we want that to be monitored, we can actually send a satellite on board a rocket and send it to space at a very affordable cost. So that is what Skyroot is aiming to do. And every day it is it's a very new startup. It has been just 4 years that the startup is operating now. And it's since it's a startup and there are very few people working in the company, every day is very different. Sometimes random problems come up, and then we are left to solving the problems on our own, and sitting down and brainstorming with the team members as to how a particular problem needs to be solved and all. So to begin with, I'd like to share a video with you all. So this video is a launch video. This was the video, like this is the video when our first launch actually happened last year in November. So I'd like to just share with you all that video.
We feel the
So when this rocket was launched, actually, it was considered as a historic movement, like event, because it was, as I mentioned earlier, it was the first private
So Vaidehi, we are losing you. Your voice is breaking. Yeah. Can you hear us? Yeah, here we go.
Hello,
Yeah.
hello.
Can you hear us?
Yeah,
Okay, yeah, it's fine now. Please
yeah,
continue.
yeah. I'm able to hear you.
Yeah.
Yeah, yeah. So yeah, as I was saying, this was a very historic event wherein a private company from India was sending rockets to space. So this event actually got us a lot of recognition around the country, fondly calling us India, right? I mean, that's a thing to say. Am I still not audible?
It's little lagging. Yeah. So Vaidhi,
Okay,
why don't you
okay.
just check it? And also, children, please, this is a webinar, so you will not be able to unmute or speak to us. So towards the end, you would be given an opportunity to ask your questions. So please write it down, whatever questions you have for Ms. Vaidehi, and she would be able to help you, right? And also in the chat, please ask only relevant questions. And if there is any, feedback, you can just put it out, or else, you would be, removed from the meeting if you're sending any spam messages. Okay. So let's continue the session. Okay. So listen to the session and write down your questions. And towards the end, everyone would get an opportunity to, get your questions out, and Ms. Vaidevi would be able to answer the question. Yeah. Yes, Vaidehi, you're there. You can continue.
Yeah, I'm here.
Yeah, please. Yeah, now we
Let me
can hear you
know
properly.
if my voice is yeah, yeah. Okay, all right.
Mm,
So I'll
mm,
just
mm.
play the video for you.
We feel the launch along with you. We enjoy the launch along with you. Just 10 seconds to launch.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Event number 96 completed.
And we have a successful
Event number
liftoff
98 completed.
of Vikram S rocket. I think I should be able to show you the jubilant environment here in the
Busy
Mission
track.
Control Center, where the entire team is celebrating the launch and the spin stabilized rocket. Views from the launcher camera. In a few seconds, the vehicle will undergo the condition of maximum aerodynamic pressure, followed by the motor burnout, and we will get you those confirmations shortly.
Wow, that's a very nice video. You should have felt super proud and super enthusiastic, right? When excited, I would say, when this happened. Were you there? Uh,
Yeah, yeah. So
mm.
I along with my, I'm audible, right?
Yes, yes,
Do
you're
let me
audible.
know if I'm not.
Yeah.
Yeah, yeah.
Mm.
So this launch, it happened from the Harikota launch base, which is there in AP. And yeah, it was a super proud moment. I, along with my teammates, we were in the mission control room. From the mission control room, we can actually see where the rocket is going, at what altitude it is currently, with what speed it is moving, and all. And yeah, it was actually a moment of satisfaction and relief, because as the countdown proceeds, we were actually holding our breaths, and everyone's heartbeat was racing, because this rocket, we were working on it since the past 2 years, day and night. We're continuously working. And the thing with rocket is, it is an extremely complex machine to design. Anything can happen on the day of the launch, and the mission can turn out to be a failure. What could have happened is that the rocket could have just blasted off on the launch pad itself, or the rocket could have blasted off midair. So there are many possibilities which can happen, and the reasons for them can be as minute or as silly as anything. So anything can happen, anything unpredictable can happen, like on the day of the launch. So when this launch actually turned out to be a success, it just gave me and my other teammates additional boost, that yes, space sector in India, it is growing, and it is headed in the right direction. We are not doing something which is not impossible. you know we are working towards something, and in future this is just going to develop more and more. As in, now we have developed a rocket which is just 10 meters in height. In future, we'll be developing rockets which are 20 meters in height, 30 meters in height. And this rocket's weight was 500 kgs. In future, we'll be coming up with more heavier rockets, say 2000 kgs, 3000 kgs. And the work is subsequently going on like in inclination with that. And would you like me to share more videos concerning to the day-to-day activities that go around in my company? I'll
Yes,
just
so that was my next question. So, because pretty interesting, and this is not something that you see every day, right? There are a lot of other companies and industries that we have seen and that we have visited, or some of our relatives are working, right? As far as I can remember, I don't know anyone, my relatives or relatives of my friends or relatives of relatives working in, space tech. So I'm super excited to see, what you have for us, right? If you can show some more insights on, how you work and what are things happens in your workplace, that would be really great.
Correct, correct.
Mhm.
So I'd like to start by saying that every small component and subcomponent of this rocket, we
Mhm.
have developed it ourselves. We have not got any parts from outside. Of course, you need to get the materials and all from the vendors, but everything else apart from that, we have developed it ourselves. Like we have our own manufacturing facilities, testing facilities, wherein everything that we design first, we get it tested, right? So I'll just share some of the videos. Like to share one manufacturing video. So it just covers various aspects of the design and how the engineers are designing it themselves and assembling the rockets part by part themselves. So I'll begin it. Yeah,
Really cool video. And I think
yeah.
kids also loved it. Even I am seeing some, comments from the kids where they are trying to identify, which material is used and, how it's been made. So super cool. So yeah, we saw something that is, we are putting the rocket together and doing it, right? So before you go for a launch, I'm sure that you would have a lot of facilities for testing them out, right? Before you put it to the actual field, right? So how that is actually, because when you test it in a very controlled environment, right? But still it's a rocket, right? So how do you manage that? Do
Correct,
you have
correct.
something? Yeah.
Yeah. So
Mm.
yeah. I have one video which I'd like to show. It's like testing of the engine, which was used in the firing of the Vikram S rocket that we recently launched. So few things which I'd like to say is before testing, we thoroughly first we develop the design, using all the complex mathematical equations, all the physical equations that are there. We first develop the design and then analyze it thoroughly. These are all done with the help of computer simulations. We get some numbers, right? That this is the amount of thrust that the rocket should achieve, and no, we but like this is when we are doing all this design on computers and all, there's always a lack of confidence in our mind that this is something which we have designed in computer, whether it will actually work in real life, right? And for that we need to actually test the thing, right? Whatever we have designed on a computer, we need to physically test it. So there are many testing facilities available all over India. We go to those facilities to test the design. So
Vaidehi, your voice is breaking again.
I'll show you the video of the engine we had designed. We had
Okay.
is it fine now?
Yeah, it's fine now. Yes.
Okay.
Mm.
Yeah. So this is I'll just play a video regarding then we tested it in a facility, and then we were very happy after the test turned out to be successful, as in whatever numbers we had predictions, they actually came out to be true. From the or the required thrust that we wanted from the engine, those numbers were correct and they were aligning to what we had actually calculated. I'll just play the video. Yeah. So this was the engine test that we had conducted. And I'm not sure if you know what are the fuels that are used in rockets, but here I'll just like to say that the fuel that creates such high energy plumes, it is actually ammonium powder. And you guys must be studying many compounds in chemistry and all. It's a reaction between ammonium powder and ammonium perchlorate. And when we just ignite it, it creates a very high amount of thrust. The thrust is actually of the order of like 8,000 kgs, as in 80,000 newtons. I'm sure many like students must be understanding what a newton is, right? So that's what. And also, one last video I would like to play. It's also the development of some small thrusters that we have on the side of the rockets to actually spin the rocket as it goes in the air. Since it's a small rocket, what is actually required is that it needs to be spun around its axis so that the vehicle keeps pointing in the right direction and it doesn't wobble or go haphazardly or spiral out of its way. So I'll play this video as well. Yeah. That's all.
Got it.
So yeah.
Mm.
So one thing here is the physics involved in all these things. It's the basics of the physics involved is something which you learn in your 8, 9, 10 standard itself. As in when you are applying a torque or applying a side force on the cylindrical object, by how much velocity or by how much angular velocity it will rotate and all. And this is just a simple physics that you'll learn in your 8, 9, 10th physics as well. And when you apply the simple physical laws and actually develop something out of something physical, a physical machine out of it, it is actually very satisfying feeling. Also, it becomes very intellectually challenging as well. So yeah, that's all I would like to say about all the
Mm.
work that is going on around in my company.
Okay, got it.
Yeah.
And so I have a lot of questions coming up from the students. So one student, his name is Shyam Gupta, and he has asked, to launch the rocket. I understand it's sent by escape velocity and positioned into space. But how long it stays there and what updates we get generally from the launched rocket? Can you share some insights on that? That's his question.
Okay.
Mm.
It depends on the kind of rocket that it is, right?
Mhm.
If example, if your rocket has some satellites that it requires to go into space, what happens is that it will leave at very high velocities from the launch pad. Not very high velocities, it will leave at a small velocity, but as in when it goes up, it will reach velocities that are corresponding to like Mach number 10, Mach number 12. Now when I say Mach number 12, it means that the rocket is actually traveling 12 times the speed of light. Now if you know, the speed of light is 340 meter per second. So when the rocket goes around 100 and 120 kilometers from the surface of Earth, it would be having a speed of around 4,000 meter per second, or 4 kilometer per second. That is the speed at which it travels. And eventually what happens is that the topmost surface of the rocket, it disintegrates, so that the satellite which is placed inside, it is let out and it is placed into orbit. I hope I'm also like I'm answering the the velocity question, that at what speed the rocket is launched and all. When
Okay.
bigger rockets, when they are launched, they have a very small speed, like 20 meter per second and all, but they have a very high acceleration, which makes the speed go from 20 meter per second to actually say 400 meter per second.
Okay, okay. And there's also a question from Nitin, who's asking, what kind of engine is used in the Vikram rocket?
Yeah.
Mm.
So if you know about I'm sure you would not know what propulsion is and all, but if you know about the fuels, as in when we want to drive a car, what fuels are we using? We are using basically petrol and diesel, right? In the Vikram rocket, what fuel we used, it was actually a solid fuel, as in the propellant is a solid propellant. It is a mixture of the fuel and the oxidizer. It has just to be ignited. So, kind of explosion happens, all the gases come out very fast out of it, and it creates a thrust. Now, this was a solid propellant. There are, liquid propellants as well, wherein one example of liquid propellant is the cryogenic liquid propellants, wherein, H2 and O2. These are separately stored in their liquid formats at very low temperatures, say minus 200 degrees Celsius temperatures they are stored at, and then they're allowed to mix. Now H2 and O2, when they mix, they create water and a lot of energy, The energy is the amount of, around like 10,000 to 20,000 kilonewtons, right? So that those are the liquid propellants which I'm talking about. But yeah, in Vikram S, we used a solid propellant, and the solid propellant is it's a like cylindrical solid propellant, and in the middle of it, it is star shaped, like the hollow is star shaped. The shape is designed such that it provides us maximum amount of surface for the solid propellant, like the solid propellant to burn, so that it creates the maximum amount of thrust. I hope that answers Nitin's question.
Yes, yes, it is. I think, a lot of kids had similar question and you answered it to that as well, right? And also, I think on our very next topic, even a couple of kids have asked, what is exactly, aerospace engineering, right? In layman terms, as simple terms, what we can understand from, aerospace engineering, and what is it all about?
Correct.
Mm,
So to simply explain,
mm,
is my screen visible? To simply explain, aerospace engineering is it's a primary field of engineering concerned with the development of either an aircraft or either a spacecraft, right? This is to put it simply. But in the end, it's a complex integration of many different subdisciplines. Like as in we have when you have to actually design a spacecraft or an aircraft, there are many things that you need to take care of, and all these things need to fit together perfectly so that the final design it actually works, right? So in aerospace engineering, if you think about it, there are like 5 to 6 different subdomains that come up. First one is aerodynamics. Aerodynamics is basically the study of how air flows around objects, right? It's that. So then the second comes propulsion. Propulsion, as you people asked, it's the fuel that gives the required push to the vehicle. So propulsion is the study of that. And then there's this third subdomain known as structural mechanics. It is a study of structures, basically. How, when many structures are fit together, how they will function, whether they'll be, able to handle the very high stressful environments or very high loads they face when they move at very high velocities to the atmosphere, right? So structural mechanics is basically the structure of basically the study of integrated structures, right? Like rockets or aircrafts. And then there's something known as flight mechanics, guidance, and navigation. It's basically the subject wherein you can uh, uh, you get to study the trajectory of a vehicle, or you get to design the trajectory of a vehicle by simpler. To start with, it starts simply with Newton laws, right? I'm sure many kids must be studying these basic equations such as V is equal to U plus AT, S is equal to UT plus half AT square. They must be having simple problems in physics, such as, if you are pushing an object with a certain amount of force, with what acceleration it will move. So, like, concerning to aircraft and spacecraft, flight mechanics is similarly the study of that. It's just the study of study of it. Like, if you are pushing an aircraft and spacecraft into space with this much amount of force, with what acceleration it will move, with what velocity it will move, with what is the angle of what is the angle which it should make with the air, so that it goes into the particular trajectory which I want to. Now, now when you speak about aircraft and spacecraft, they actually have a 360-degree of freedom, right? They can move in the X direction, Y direction, Z direction. They can even rotate along all the three directions.
Okay. So Vaidehi, we are losing you.
X direction.
You are not audible, Vaidehi. Can you just check it once?
Direction, Z direction. Simply put, this is a study of all that. Um, is it all?
Um, Still we couldn't hear you. In the meantime, kids, I see that a lot of you are asking questions about how rockets work and more into the physics side of it, right? So for this, I have an exciting news for you. So next week, Sunday, same time, we are going to have another talk with a scientist from a space research center, right? And he would be explaining you about the physics behind these orbiting satellites and the rockets, right? And more in-depth discussion would be done by the scientist itself, right? And hope to see you see all of you in that session, right? And we will be sharing you the details about that event as well. So do join it, where you get more in-depth information. And I'll also be sharing you the invitation to the next week's seminar here. So please do register for it, so that you get the invite to it. Okay. And secondly, I am seeing a lot of other kids are asking questions, that how does space travel work, right? How can humans go into space, right? So for that, previously we have conducted a Plato talk with one of the experts, who explained how space travel looks like and how humans can actually go to space, right? So we would be sharing a video of it in YouTube today, right? And I would be sharing it to you as well. So to know more about the physics behind orbiting satellites, we have another session coming Sunday. I would be sharing you the link shortly in the chat here and the comment box, right? And to know more about the space travel and how humans can go to space, we are having a video where we have already had a speech with one of the expert, and we would be posting that video in YouTube and sharing it to you as well, right? So on these two subjects, you can do this to get more in-depth information. Now I think Ms. Vaidehi is back. Is Vaidehi here?
Yeah. Am I
No.
audible?
Yes, loud and clear. Please continue.
Okay. So where did you lose me?
So when you were, explaining about the difference in aircraft and spacecraft with respect to the subject,
Okay.
the flight mechanics guidance, yeah.
Yeah. So as I was saying, flight mechanics, guidance, and navigation, it's the study of how your aircraft, which what path it will actually follow through the space. And it doesn't simply follow a path, it actually revolves around its axis as well. It can spin around its axis, it can roll as well. So, it's a study of all that, right? And then I'd proceed to avionics. Avionics is basically nothing the electronics that is required in aircraft and spacecraft. It is something which forms the brain of the spacecraft. All the signals are being set up through the computer, like to the computer system that is stationed in an aircraft or a spacecraft, and it is developed through the electronical instruments and all. And that is what avionics means. Avionics system, it is basically the computer system of it forms the computer system of a spacecraft or an aircraft. One of its like one of like the major applications of avionics is when the aircraft is moving into space, or the spacecraft is moving into space. You'll have different sensors on it which can actually sense what is the temperature of the air around me, with what velocity I am going. So these data, with what velocity is my spacecraft moving, what orientation is my spacecraft moving, also the camera pictures that we receive from outer space and all, and to send the signals back to the station on Earth. These are all done with the help of avionics, right? And then lastly, I have material science. So material science is nothing but the study of different materials. So as you know, these aircrafts and spacecrafts, when they are moving through space, they need to be strong enough. They need to be durable enough to endure the harsh conditions that they are facing in the air or in the space. So the material science is when it concerns to the aerospace industry, it's the study of different materials, how you make use of lighter materials, to reduce the weight of your spacecraft. How can you use a material which is light also, but it is strong also, so that your vehicle is not just light, but it is very strong as well, right? And a material should also be such that if it is facing a lot of heat because of atmosphere, it should be able to endure that, right? Even if a material is going say 2000 Kelvin and all, it should be able to withstand that temperature. It should not disintegrate at that temperature. So all in all, material science is the study of different properties of materials, and the kind of materials that we require, particularly for our for any component that are involved in any of the like spacecraft or aircraft. To sum it up, aerospace engineering is the study of all these disciplines integrated together.
Okay, great, great. I think, it's a good explanation on different aspects about aerospace engineering, right? Now, since, we are talking about the future of spacecraft, right? So I want to understand from you, right, on how is it looking like? There's a lot happening, right? So what can we expect in the coming years, especially related to space technology?
Correct, right.
Mm.
uh, I'll just go to the slide which would be wherein I will explaining that.
Mhm.
So first of all, I'd like to start with what is happening in the world. Okay. So all of you must be hearing a lot about NASA, about SpaceX, about Blue Origin, about Virgin Galactic. So I'll just start with what is happening in the world in the space industry. So to start, the space sector is one of the fastest growing industries in the world. There was a time in 2000 when the digitization, or the information technology sector was at its boom. Lot of jobs were being created around that era, and now is the time when the space sector is booming, right? So what is happening is that we are able to reach space in very less cost, and year by year the cost of reaching space, or the cost of manufacturing a rocket, an entire rocket, the costs are reducing. As of now, if you see something like a PSLV rocket which is manufactured by ISRO, The cost of its manufacturing is 200 crores. And the bigger rockets like the Falcon X rockets and all, the cost of manufacturing it is 800 crores. When as years go by and as new technological inventions come up, these costs can actually be reduced from say 200 crores to something as less as 10 crores. So we are in a phase wherein common people can also send their satellites into space, because space travel is getting very cheap compared to how it was earlier. And yeah, as I was saying, the cost of launching satellites, it has gone tremendously down. And there is intense competitions among all the space industries, because everyone wants to bring their developmental costs down so that they are able to gain more customers and then they are able to generate more revenue. And talking about SpaceX cost competitive launch services are such that they are actually developing rockets which go into space and then they land back on Earth. Like they go into space, deploy their satellites, and land back on Earth. If you see the aircrafts with which you have aircraft travel, uh, uh, they are used multiple times. A life of an aircraft must be 200 flights, 300 flights. But with the rocket, it's not so. When it does the job of sending its satellite into orbit, it just disintegrates into space, right? But a Falcon 9 rocket, it's the first kind of its rocket which actually the company reuses. It lands back on Earth after sending its satellite into orbit. And with the cost coming down and with the new technological inventions coming up, there are also new avenues in space that are opening. One of them is space tourism. You know, 20 years down the line, who knows that we might be, going on a trip to moon, or we might be going to a hotel which is stationed in the space, right? Because things like this are like the cost of these things are getting less and less, and it's a possibility that space tourism and space travel, it is going to be accessible to human beings, like simple human beings like us as well. No need for you to be an astronaut to be able to go to space. You can just maybe board on a space cab and go to some space hotel that is out there on a trip, right? So this is what is happening in space around the world. And talking about space in India, up until now, the Indian Space Research Organization was the only entity available to, have this access this industry in India. Based on some PSLV stats, PSLV is the Polar Satellite Launch Vehicle of ISRO. But it is the vehicle which ISRO has flown the most. Like most of its operation is based on PSLV. And PSLV, it has launched a total number of 328 foreign satellites from 33 different countries. What this says is that PSLV is also offering very, cost-effective launch services to its neighboring countries. That's why they are coming to India, so that they are able to launch their satellites in lesser money. And revenue earned through these launches is around $25 million and 189 million pounds. So ISRO is also doing a lot of business when it is helping our neighboring countries or many countries to launch their satellites into space. But the thing is, like the company like SpaceX and many other companies, they are in like very big, not big, but they are also in a very good competitive space with India, right? SpaceX is already doing huge technological advancements and they are way ahead of something like ISRO. So to remain competitive in the market, to not lose its competitive edge, to retain its customers, ISRO has to invest in R&D development to develop new launch systems and new space technologies. So to develop that, to develop new technologies, it is not something which ISRO can do on its own. because its main job is not to do business or not to generate revenue. It has a lot of it has a lot of funding from the government itself, and its main job is to aid in the development of the nation through R&D activities, which it does. Right. Basically, for the development of a nation, these activities are need to be carried out, not for for doing business. So for that, what happened is that the private sector, it was opened up for space in India. So India's private sector will now, what is happening now is India's private sector is participating in India's space journey through a new agency known as InSpace. So I just tell you what InSpace is. On June 24, 2020, that is 3 years back, the government of India created a new organization known as InSpace. So InSpace is just a single agency which is going to boost the commercialization of Indian space activities, which means that more and more private companies can easily set up their companies and develop their own space technologies, to boost to give a boost to space business in India. And so what has happened is that because of this in space body, which was developed 3 years back, the number of space companies in India in the last 3 years, they have grown tremendously. So if you see something like 10 years back or 9 years back, you would have really no opportunities to work in a space tech company in India aside from ISRO. But now what has happened is that in the past 3 years, starting from 47 startups, space tech startups in 2021. Now, currently, India has 104 space startups and 36 space tech companies, which are actively, doing business in India. So this was not at all the case 10 years back. So what it actually mean, like doing a degree such as aerospace engineering 10 years back, is that it would mean that there's no place I can use the skills which which I've learned during the course of my BTech. It would just mean that, if I'm a passionate space enthusiast, if I'm someone who is fascinated by rockets and space travel, it would just mean for me to get out of India, go to US and search for opportunities over there. But now what has happened is that similar kind of opportunities and in very huge numbers, they have opened up in India itself. So
Yeah, I think
that is,
even
yeah.
there is a question around it. So how does it look like in India about the opportunities, and what are the probable career options that they can have in India itself. So that's actually one of the questions. So if you can also show us on what is happening currently in India and how does it look like, especially in the space tech.
Correct.
Mm.
So yeah. So as I mentioned, like India currently has 104 space startups and 368 space tech companies, right? So you see there are n number of companies where you can work at. And yeah, you basically need to be a mechanical engineer or an aerospace engineer to be working in these startups, right? Like you would normally think that, right? But there are like there's no need for you to be just an engineer to be able to work in space tech companies. For example, in my company, I have a lawyer who is specialized in space laws, right? So this is actually something new. You can actually be a lawyer who specializes in space laws, because a lot of new laws in India specifically are being developed so that the space industry gets a boost in India. You can also be a computer programmer and work in space tech companies. In basically every aspect, like every subdomains of aerospace engineering that I explained, all of these things, they are happening based on simulations that we need to perform on a computer. And for that, if you want to develop your own softwares, right? If you want to develop your own softwares, you need to be a good programmer. You need to be someone who can be a good coder and who knows the basics of mechanical engineering or the basics of electronics or the you need to be just very good at physics and maths. So yeah, that's what you can be a very good electrical and electronics engineer as well to be able to work in this and these companies. As I said, like, there's a lot of avionic systems on aboard the space onboard spacecrafts and aircrafts, which actually form the brain or the network of information pass on an aircraft or a spacecraft. And then it's like you know uh, when I was talking about propulsion, I was talking about how H2 and O2 they mix and how thrust is created. So it's basically chemistry, right? So to bring forward new innovation or to bring forward new propulsion technologies, you can be someone who is very proficient in chemistry as well. You can develop your own your own propellant, a new class of propellant which gives a very high amount of thrust. This would all require you to be good in subject like chemistry. And pushing further down, like if you can even be a biologist and work in the space industry. What a biologist will do in the space industry is that he will develop food pills which astronauts will eat, and which will help them sustain the harsh environments, zero gravity environments which they are facing in the space, right? A biologist would devise the space suits, comfortable space suits for the astronauts. This is something known as astrobiology. Also, astrobiology also means development of plants and flora and fauna on outer space. So these are the different kinds of things apart from just technical, very core technical subjects like mechanical engineering and aerospace engineering, which also open up opportunities for you to work in space. that's
Okay.
that's all, Vasant.
Okay. Okay. So which means, as long as you have passion and interest towards space, right? No matter what kind of specialization or the subject that you study, you still have a lot of scope to explore, right?
Correct. Also, I just forgot one thing. So
Mm-hmm.
in many universities and also in IIM Bangalore, there is a specific course known as MBA for aerospace professionals. So which would mean that it would make you proficient with the business that is involved in the aerospace industry, right? So you would be a professional who knows how to drive business. You'd be strategist who knows how to drive the business of your space company. So there's a lot of scope in MBA in the aerospace sector as well. That's it.
Right. I think there was a question around it, so that since you were briefing about this, probably I can ask you that question. Just give me a minute. So there was a question on what kind of entrepreneurial opportunities that we have related to space tech was a question actually.
Correct.
Mm-mm.
So I'll the opportunities or the entrepreneurial opportunities are limitless. Like something which you cannot think about today, but something it might be something that you come up with an idea, say 1 year later. It is something like that
Mm-mm.
because n number of new opportunities are opening up every day in space,
Mm-mm.
or n number of concepts and design concepts are being developed and innovated every day. So it might so happen that you get an idea not today, but 1 year down the lane because of the technological advancements that are happening. Like in aligning to that, I would like just give you a glimpse of what is happening in India, right, regarding the various entrepreneurial opportunities that are available. So I'd like to tell you what other entrepreneurs are doing. Okay, so I'd start with the startup known as Digantra. Digantra is a space situational awareness observatory in the hill state of Uttarakhand for tracking satellites and space debris in the low Earth orbits and the geosynchronous Earth orbits to offer global space traffic management operations. So what this means is that as the number of satellites which are being launched into space are increasing, there's a lot of traffic actually there in space. Like we know about road traffic, we know about air traffic, but we haven't never heard about space traffic. Now, space traffic and space debris is caused because of asteroids or because of the rockets that are being launched. After launching, they are just left there. Okay, they are just left floating there in space, right? So there's a lot of space debris in space out there, and there are just n number of satellites, huge number of satellites that are there in space, and you need to actually manage them. The traffic that is out there, you need to actually manage it. You don't want satellites bumping into each other, and then different companies, suing each other for destroying their satellites, right? So to manage the space traffic, this Diganta startup, it has been developed. So this is something very innovative, right? No one could think that, oh, this is an entrepreneur, this is an actually good idea, right? Like I could never have thought of something like this had I not known like what are the things happening in space in India. Okay. And then there's one more startup which is known as Astrovon. It is a space and defense technology solutions company with a vision to make India a leader in the commercial spaceflight sector. What this startup is actually going to do is that in Asia, it is going to be the first private astronaut training facility. Also in India, it is going to be the first private training facility, and it will develop next generation of modules, which would carry astronauts into space, and it will be, supplying it to government and to commercial companies for use. As I said earlier, it will be Asia's first private astronaut training facility, and it will be giving a comprehensive training for aspiring astronauts from basic physical fitness to advanced spaceflight techniques. Right. So this is also a good startup idea, right? You are actually developing a company which would be training future astronauts to become space ready. Correct. We know that, if you want to become a pilot, there are actually pilot training courses which happen, and which are very expensive. Similar to that, this will be, an astronaut training facility, right? And then one more thing is that one more interesting startup which I know of, it is Space Aura. So Space Aura, it is something which is capturing the space tourism market. Space tourism means, enabling common people who are not astronauts, or who are not highly skilled aerospace engineers, enabling them to go into space and enjoy the beauty of space, right? Enabling them to go at a certain height in space and be able to see the earth, how it looks from the outer space, right? And how the sun looks from outer space. So this Space Aura startup, it's a startup, and its idea is that it is going to the travel to the edge of space, reaching some 40 kilometers of altitude, sitting inside a very spacious, ball kind of a space capsule attached to a high propulsion balloon system. So you can see the figure which I have attached here. This is their model concept, which they are, planning to get it operational by the end of 2025. What it will do is that it will carry people like us, tourists, into outer space, and it is a startup centering around that. And so you see, there are varied concepts or varied entrepreneurial ideas that are coming up every day in the space sector in India itself, because now in India it has become very easy to access space. And in lining to that, there are two more startups. So these are just, 5 of the 368 space tech companies that I'm mentioning, which are doing amazing, job. So one of them is Bellatrix Aerospace. It is an R&D company specializing in the development of in-space propulsion system for satellites. So what this means is that Bellatrix Aerospace is actually trying to develop some kind of an air taxi, which will take satellite from one orbit into another orbit, right? So as you see, I've shown here a constellation of satellites. They are all, orbiting the Earth in different planes, right? Now, if I want to, take a satellite from here, say I want to put it into a different orbit, I just want to change my location of the satellite so that I'm able to get a different data or the different viewpoint of the Earth. What Bellatrix is aiming to do is that it is going to create new propulsion systems which can actually carry one satellite from one orbit into another orbit. once we set a satellite into orbit, it is designed in such a way that it is going to stay in that same orbit for years, right? So it is very innovative that what Bellatrix is trying to do. It is their idea, as I said, it's developing of an air taxi or a space taxi, to just move a satellite from one location to another location, or from one elliptical orbit to another elliptical orbit, right? And then the last one, which I would like to say, is Dhruva Aerospace. So what Dhruva Aerospace is doing, it is developing exceptionally small satellite systems, to go into space. So as the electronics technology is also advancing, the satellites, which have many electrical and electronic instruments on board, they are just getting smaller and smaller and smaller in size. So this is what Dhruva Aerospace is doing. They are developing micro and nano satellites, which could be sent into space. So these are just five of the five very smart ideas uh, which entrepreneurs are capitalizing on, and expecting to actually develop a huge revenue out of it.
Right, very insightful. Because even I was under the impression that only space companies launch rockets into space, but I got to know that you have companies developing the traffic management system, and also training of pilots who would go into the space, and also there's a company who is developing the tourism activity, right? So
Yeah,
wonderful,
yeah.
right? So to know all these ideas from different entrepreneurs and how they're doing. And I'm sure that some of these ideas are less capital intensive, right? You don't need a huge capital to uh, do like how you do it for a rocket launching a startup, correct?
Um, that is actually not true.
Mm-hmm.
Any kind of what I've seen is any kind of activity that is related to space, it
Mm-hmm.
is highly
Okay.
capital intensive.
Mm-hmm.
But these days, what is happening is that the
Mm-hmm.
space industry, it is on such a big rise that it has attracted the attention of investors, right?
Mm-hmm.
People who have huge amounts of money. For
Mm-hmm.
example, I'd like to point out the fact that one of the primary investors in our company, Skyroot Aerospace, was the founder of Myntra. As you
Mm-hmm.
know, Myntra is a very big e-commerce platform, for shopping, right? So he was the founder of Myntra. He was the initial inventor in our company, right? And yeah, so that's what I mean to say, that nowadays, these companies, they are attracting the attention of investors in India and from abroad as well. Because what India has is what India could do is, whatever technology is being developed in US, India can develop it at a lesser price in India,
Mm-hmm.
right? That is one thing. But also the backdrop is, it is highly capital intensive, right? For example, someone comes to my company and gives me 500 crores and says that you build rockets. uh, it is going to be a very difficult task. I'm not saying it is impossible, but even 400 crores is very less for a space tech company. That's what.
Okay, okay. But good to know that a lot of people are now knowing that space tech is the future, and they're trying to invest in such companies so that they can actually come forward, right? So that's a good news, I would say, right? And
Yes, yes.
right. So can we take up some questions now from the students? Right. I think they're coming up with a lot of interesting questions, I would say, right? So,
Okay, okay.
firstly, I think Mamata have asked what type of food can we eat in space. I think before you answer to it, I think Mamata, we do have another session which we conducted previously, where we discussed on human travel to space. So that video would be uploaded to YouTube today. Please subscribe so that you get an update once it is done. And the answer to your question is explained in detail by our expert in another video. So please see that video. And the next one is, how boosters work. It's a question. So, do you have any insights on it, Vaidehi?
Okay. I'll just show. I had an image where there were two solid boosters attached on this rocket. Okay. So I think this is the photo. of the space shuttle, what it does is that this rocket launch vehicle, it actually transfers this space shuttle into the International Space Station. As you must be knowing, International Space Station is it's a integrated body, of around a size of 12 rooms, wherein scientists actually go and stay there and conduct experiments in space. So how such a big vehicle is transferred into space is that there are these two solid boosters which are attached on the main central engine. So mostly boosters are made of solid propellants. Okay, and how they work is similar. The basic concept is similar. A Diwali rocket, right? You just light it, with a matchstick. It acts as an igniter. There's an explosive material inside. After after getting in contact with the fuel, which is like with the igniter, it just explodes, right? And it creates a huge amount of thrust which propels it to go above, right? So boosters also have a similar concept. As I mentioned earlier, uh, it's a mixture of an oxidizer and a fuel, right? Fuel needs something to oxidize it, okay? And after oxidation, a tremendous amount of energy they are released, right? And tremendous amount of energy is released. By that I mean that gases are let out with very high velocities and with very high temperatures, right? And these gases, when they come outside of the rocket, they push the air, right? And if you know what Newton's laws are, these gases push the air downwards, and an action has an equal reaction, right? So this thing just causes the rocket, the air then in turn pushes the rocket upwards, right? Huge amounts of gases with very high energy, they come out, and it just propels the rocket forwards. So this is how the solid boosters work. So in this image,
Mhm.
these two side cylindrical things, they are the solid boosters. And in between, these are not in between is an engine tank. And in that engine tank, actually, two fuels are there which are stored in their liquid form, and they are not solid propellants, they are liquid propellants. As I mentioned earlier, they are nothing but liquefied form of H2 and liquefied form of O2. So as the rocket goes forward, they mix, and huge amounts of thrusts are again created.
Okay, okay, great, great. And also there is a question from Kavish. He asked upon what subjects, should we focus more to that is helpful in space technology. But I think you already answered to it. It can be either physics, chemistry, mathematics, computer science, even law, right? That will be useful in space.
Yeah, yeah.
As long as if we have passion towards space, we can always relate to what we are learning, because it's just another environment that we are building, right? So anything that we learn should be useful there. So I think that answers that question. And there's also an interesting question from one of the students. So how does these companies earn money?
Correct. So as I already told, it's a very highly capital intensive industry.
Mhm,
So the possibility is that this company won't earn any money, even after 10 years after its inception.
mhm,
Okay. It solely works on the basis of the money which it receives from founders.
mhm,
To get an actual rocket operational, it might take 5 to 10 years of R&D activities. It
mhm,
might take one or two failed missions to get the mission actually successful in the third attempt and all, right? It
mhm,
might take a period of 5 to 10 years, right? So till then, they have to rely on the investors' money,
mhm,
right? But how they actually make money is that there are many companies around in the world. What a rocket actually does is it will transfer a satellite into space, right? Now, why satellites need to be spent into space? Now, many companies, they want to send their satellites into space so that they can get some data. What kind of data do people want? So one kind of example of it is Google Maps. How does Google Maps work, right? It is solely working on the basis of satellites. Satellites are tracking the roads and all, and representation of it is created, and we are able to see the different roads, right? So this data we are getting from satellites. From satellites, we can see a match. Because of satellites, we can see a match which is going on around in any part of the world, and it gets easily available to us through internet, right? So uh, so these satellites, they need to be launched into space, right? Who will launch the satellites? The rocket will launch the satellite. The company which is developing the rockets will launch their satellites, right? Now, the satellite people, because they want to get data, they want to send their satellite into space, right? So obviously they have to pay the rocket to send their satellite into space. It is to put it simply, a rocket is just a taxi for a satellite, right? And to go into space, you have to book the taxi, right? And you have to pay a certain amount to go into space. I'd like to just state some facts, like how much it actually costs to send something into space. Okay, so to send even 1 kg of a satellite into space, we actually, the rocket company will actually charge you something around 10,000 to 20,000 million dollars. So that is actually the price of sending something as small as 1 kg into space. So yeah, of course you need to be exceptionally rich, to pay the rocket that much, to send your satellite into space. So that's how, rockets are generating money, by sending people's satellite into space, or yeah, that's all.
Okay, okay,
They are generating revenue by taking people's satellite. Yeah. And
right.
also one more thing which I'd like to mention is that because of technological advancements, and because of the satellite size getting smaller and smaller, and the like manufacturing cost of satellites and even rockets getting smaller, more and more rockets, more and more satellites are going to be spent in going to be sent to space. So so the thing is that the companies who are manufacturing rockets, they are just capitalizing on this. They know that people want to send their satellite into space, so they know what they have to do. They have to develop their rocket at a very small at a cheaper price than what other companies are doing, so that more customers come to them. More customers, so then more customers book only them, not the other companies, to send their satellites. It is something as simple as more people using Uber over Ola, because might be Uber is more efficient than Ola. It is like that.
Yeah, I'm really happy to hear that, we're making references to, what we are using daily, because that much, space tech has evolved. And, very soon I see that, it would be a normal practice to be even talk about going to space or doing something related to space, right? So
Yeah,
I'm
yeah.
really happy and thrilled to hear that. And also there is a question from one student, what options are available, for 9-year-old kids to start gaining knowledge in aerospace or space technology, is the question.
Okay. So for 9-year-old, I think you just need to be, very good in subjects like maths and science. That's it. If you are like very good in the subjects,
Mm,
you'll do good later also, right? That's what.
mm,
Also, the thing is that, like, for a 9-year-old, aside, of course, I know there is YouTube, there is Google, and on YouTube also there are many channels, which I can suggest, for them to gain knowledge about how actually rockets are working, or how actually satellites orbit into space.
mm,
And I think it's YouTube is a very good teacher. I think all of us are taught by Google and YouTube, so you can just learn through them, because it would give you a huge amounts of knowledge, right? But also apart from that, I would like to focus on this one fact, is that if you're down the lane, you want to be a very good aerospace engineer or a mechanical engineer, you need to be really good in your physical and mathematical concepts. And and you need to develop them from a very young age, say from 10 years of age. And a good way of that is a good way of doing that is participating in the competitive physics science, like competitive science and maths exams,
mm,
because they are just very good to sharpen your physical concepts.
mm,
And down the lane, it would just make you very smart and very intelligent, because in the end, rockets are all just maths and science, and you just need to be very good in solving the equations and understanding the equations. And if you are focusing on preparing for competitive exams, it's just going to be very good for you to gain very solid foundations in physics and maths. Aside from solid foundation, it will help your mind to get very creative in this subject,
Mhm.
creative and also very intelligent to understand the complexity of the subject as as you take up advanced level of the subject.
Right, right. I think, a lot of students, our Plato students here would relate to it because they learn about the science concepts, especially physics and maths, through, robotics and coding, where they physically see how this concept is being implemented in the actual world, and they understand the applications part of it, right? And I'm sure, what you said is that, the more creative they become, the more innovative they become, right? Through understanding these concepts would open up a lot of opportunities down the line, right? So I think that's a good sign, and a lot of kids today are now focusing on that aspect. And really, on this moment, I wanted to thank all the parents as well of these kids who have actually taken the effort to help them develop interest in science and technology through practical projects, right? And I'm sure that today, as Ms. Vaidehi told, that it's very important to be creative and innovative and understand the concepts of science and mathematics from basics, right? And an innovative way to do this is by giving them an hands-on experience. So I'm sure that you have taken a good decision, and your children are in the right path, right? So happy to hear that from Ms. Vaidehi. And a couple of questions, Ms. Vaidehi. I think we're running short of time, but a lot of enthusiastic
Okay.
students are there. So just wanted to have some questions with you, right?
Okay. Okay.
There is one question about like, do we get any kind of exhibition or facility tour available at aerospace facilities where kids can check out, or parents can take that an opportunity to bring kids to such kind of places to create interest?
Um, I'm not sure whether such kind of exhibitions happen, especially catering to students and teachers or school students.
Mhm.
But what I think is that school tours and all for students, are must be happening where school students might actually visit ISRO facilities and see how the things are working, or how the rockets are being manufactured, or how small systems are manufactured.
Mhm.
So I'm not aware of any exhibition as such wherein we can see how things are getting manufactured.
Mhm.
Uh, 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 but yeah, I think maybe you can visit ISRO facilities and go in there and just check, because ISRO, I think it does allow visitors to just check and check out the science that is happening. It is open to common people. That's something.
Okay, okay, got it, got it. And this is one interesting question from Badmini Priyadarshini. So she asked, how rockets will be in future, like how it will be. Like, what is your thoughts on that?
uh, um, how rockets will be in future? Okay,
Mm, mm,
so uh, my thoughts on it might seem pretty much exaggerated at this point, but looking at the speed at which advancements are happening, I think rockets will be such that you are able to go to Mars
mm,
and have a life over there, right? Having a life is a totally different thing, but rockets will be something like people from Earth are going to Mars. So interplanetary space travel is happening. Rockets will be like that,
mm.
something like a cab traveling from Mars to Earth, or back to Mars, something like that. It is sure a possibility in the coming 20 to 30 years.
Right, right. I think, everything is possible considering the pace at which, these companies are coming up and the kind of technologies that are working. And moreover, I am super confident because of, the kids today, right? Because they are going to lead the future, and these kids are super interested, and they all are very excited to do things because they were born with technology boom, right? Not like our area or our era, right?
Correct.
Right, so
Correct. Correct.
they come up with all these possibilities to solve a problem which we couldn't contemplate, right? So I think we are in good hands, and a lot of kids today, I think they would be inspired to start a career in space tech, and they would be getting started with their subjects and uh, really proceed in this direction. So on your thoughts, like what is that you want to convey personally to all these kids who has joined us, and who's listening to us both in the Zoom and the YouTube, because in Zoom we couldn't allow all the students, so we allowed only a few students, the premium students who have enrolled with us at Playto Labs, and there are a lot of students that were watching over YouTube as well. So what is that you want to convey to all these students who have taken time to join this session and really understand from you?
Yeah, okay.
Mm.
So, like, one thing is I'd like to convey is that almost every middle class parent wants his these days the trend is that almost every middle class family wants their children to do something like computer science, because that is one field which is supposed to give you huge amounts of paychecks after just after right after your BTech. Okay.
Mhm.
But I mean, yeah, that is true. That is correct. But what I'd like to say is that, when it comes to having a satisfactory or a happy career, it is just not money that matters.
Mhm.
You need to be involved in a job which you really, really enjoy doing,
Mhm.
and which gives a sense of purpose, which gives a sense of purpose on a daily basis to you. Okay.
Mhm.
So, for example, in my case, for example, in my team members' case,
Mhm.
all of us are working as a part of a team, and our single mission,
Mhm.
is like our one mission is to just get a rocket into space, and then have customers start coming to us, so that we are able to develop a business, right? So make a rocket such that make it successful, so that we are fully operational business, like revenue generating space company.
Mhm.
So it just gives a it's very satisfying to work in a field like this, because there's a lot of a sense of collective purpose and mission that goes on. Even when I showed you the video, it was everyone was happy in that, because they had been working for 2 years on that, and it was a historic moment kind of for everyone, for India as well, to develop such a thing and make it successful in the first attempt. So what I'd like to say is that a career in something like space, it okay, fine. It might may not be something high paying like a computer science degree right after college, right? But it is going to be extremely satisfying on the personal front, right? So what I'd like to convey to students is that you just take your time. Don't just select something just on the basis that okay, this is something which I need to do so that I will get a good package after this. Like it should not be like that, because ultimately uh, uh, no sense of purpose in life is important, or a sense of doing something which gives you actual happiness is very important rather than the money. This is what I'd like to convey.
Right, wonderful. I think most of the parents today do realize what you said, and I think they would also ensure that they are giving the necessary support to their kids to really make them develop interest and inspire them towards a career which would beneficial for them, based on their interest, right? And kids, I think all of you have enjoyed this session today, and you got a lot of information on how the space industry is today and how it is going to be in the coming years, and what are the scope and how it is going to be when you start your career, right? And what are the different fields of study that are available, right? Very insightful information we got from Ms. Vaidehi. I would like to thank Vaidehi for joining us and helping us with all the beautiful information, right? and whatever limited time we had, we were able to answer to the questions that were related to this session, right? And I can see that a lot of you have asked questions related to how the rockets work and how much time it can stay in space, and how many liters of fuel is needed and things like that. So for this, we are having another session coming Sunday on the physics of orbiting satellites. And in this, this is going to be a guest from Vikram Sarabhai Space Center, and his name is Mr. Shiju Thomas. He's a senior scientist at the Space Center, and I have sent you the invitation in the chat box here, and you would be receiving it in your WhatsApp as well. Do register for it to get more information on the other aspects of what components in a rocket and other technical questions that you have asked, right? And there are also few questions around how can a human travel to space, and what happens to humans in space, and what do we eat, and how do we cultivate, right? So for this, we had completed another Plato talk where a senior scientist from ISRO have explained about this, right? And that video would be going live soon today, and you would be able to do it, right? And the same invitation will also be sent in the YouTube, and it will be pinned as comments in the YouTube channel as well, right? So you can go and do it. So please subscribe to us, and you can also get to know about more such events and sessions happening at. So, Ms. Vaidehi, really glad to meet you, and more than the kids, I think I have learned so much from you on how space tech is, and what kind of opportunities we have. Really, thanks for joining us and taking this time to help us. Yeah, it's wonderful having you here.
Yeah, Yasin. Thank you to you as well. Thank you for inviting me. It was I felt really glad giving this talk as well. So thank you for that. Yeah.
Okay, great. And also, there's one last question. I think even it was back up in my mind, right? There's one question from Karthikeya Ram. Will we go to Mars in 2050? So, what do you think? What's your thoughts on that?
Yeah, I think it's definitely possible.
Do you think it's possible before 2050? I think probably we would be pretty old at that time. Kids might be a little younger, right? But
Yeah.
any possibility before 2050?
Yeah, of course, it can happen. Anything can happen, and that can also happen. Yeah.
Okay.
Yeah.
Great. So
Yeah.
glad. I think we have answered to most of the questions. So children, if you still have some questions, you can also reach out to us in our WhatsApp or email. And as I told, more details into the technical aspect of it would be covered in the next week's session. So thank you, children, for joining this session, and really appreciate all the parents who have encouraged kids to join the session and help us do this, right? And if you have further questions, you can ask the questions to our teachers in the class, and teachers would note down the questions, and they would be able to help you with the details, right? And since we are running short of time, I'm sorry that we couldn't answer all the questions, but as I told, these talks are going to keep coming, right? Every month we are going to have a lot of sessions from experts from the industry, right? So you would have a lot of ample opportunities in the coming days as well. So stay tuned for Plato Talks, and we would be back with another interesting session with an industry expert who would explain you a complex topic in a very simple way that you can understand and develop interest, right? So until then, it is bye-bye from my side. So please take care, have a safe Sunday, and a good day. Yeah, bye everyone. Good luck. Thanks, Vaidehi. Bye.